So now that we understand how to evaluate and even solve some basic logarithmic functions or equations, let's look at the properties of its graph. Again, as mentioned, it is the inverse to the exponential function. So the starting point would be to ask the question is, what is the relationship of the domain and range between a function and its inverse? And recall, it's that the domain and the range switch. So let's go ahead and just get a graph of our exponential function. Remember, the exponential function is going to have a y-intercept of 1. Its base, and let's just deal with the exponential function 2 to the x. So that would put us right here at the point 1, 2. And then we would have 1, 1/2. And we would have, of course, our asymptote of y equals 0. So if we were now going to look at the logarithmic function, we have a switching of the x and y. And again, graphically, what that means is that we are just going to reflect over the line y equals x. So here's the line y equals x. And then let's see now in red, the point 1, 0, or 0, 1 goes to 1, 0. And this point right here, the 1, 2 goes to 2, 1. And then the negative 1, 1/2 goes to 1/2, negative 1. So this time we have a vertical asymptote. And I'm going to go ahead and just put 1, 2, 3, 4, one more point here, just so I can get a good shape. So here we have our logarithmic functions graph. Now, the domain. We even mentioned this earlier. If we look at this graph, it will never be left of the y-axis. So the domain is going to be 0 to infinity. The range, on the other hand, goes down to negative infinity. And even though it's not growing very fast, it is still continuing upward. So the range is positive infinity. And again, if we thought about the domain and range of our exponential function, the domain was indeed all real numbers, and the range was 0 to infinity. So again, the domain and range switched. Again, the thing to note about the asymptote is now here we have a vertical asymptote instead of a horizontal one. In a vertical line, well, without any transformations, it would just be x equals 0. The important points, well, again, it's all about that base. So we would be focusing on the points right around the base, or using the base. So we had 1 over a when we were at negative 1. Instead of a y-intercept, we'll really be focusing on its x-intercept. So that's 1, 0. And this is happening because again, anything to the 0 power or the input, or whenever you're dealing with log base, any base a of 1 is always going to be equal to 0. And the third point is just going to be the base at 1. So having this basic structure in mind, we can answer questions concerning the domain. So the first thing to note is, okay, we have an x minus 2 inside. So this minus 2, like always, will be causing some sort of transformation. Notice that here you can see the parentheses are explicitly put, meaning that the m is inside the x. If you were to have log base 3 of x minus 2, you would assume that the parentheses are just around the x. So you can see the parentheses are very important when you need to be explicit with where certain values are. So this first case, we have x minus 2. This is going to cause a shift to the right by 2 units. Where this one over here, notice that that is outside the function, so it's not going to be affecting the x-axis. It will go down 2. So this will affect the domain. It will affect the input. And in general for these, we want to always just set the inside needs to be greater than 0. So x minus 2 should be greater than 0. So x is greater than 2. And if we think about that in terms of an interval, 2 is the smallest value, and because we have an asymptote, I use parentheses, and infinity is the largest value. And then a little bit more on transformations. If we have our basic function is log base 3 of x, let's look at a couple different transformations. Well, we already encountered this one above. Again, notice that this is not with the x, even though it's written right next to it. You would need the parentheses around it for it to be understood to be with the x. So it is going to cause it to go up 2. And we can see that occurring right down here in the graph below, where the blue graph is your original, and you've just slid your x-intercept up 2 units. Okay, in the case of b, we have a negative sign, so it's going to be a type of reflection. This negative sign is not with the x, therefore it must be with the y's, making all our y's negative and the negative y's positive, so it's going to cause a reflection over the x-axis. In this last case, we're going to deal with h of x, where we have minus x inside. Again, be very careful. Remember, this is like a tree. You need all the parts. So this is important to note that log 3 by itself means nothing. It is just the middle of the tree. You actually need the input, in this case negative x, for it to mean something. Well, then this negative sign, multiplication by a negative, again is a type of reflection, but because it's inside with the x, it's going to be moving us over the y-axis.